Hello.
Once again, good evening, all.
Good evening, sir.
Good evening, sir.
Yeah. So in yesterday's session, we have discussed up to week 9. So today's session, we will discuss week 10, 11, 12. So let me share my screen. So first, what is conflict serializable, right? A schedule is called conflict serializable if it is can be transferred into a serial schedule by swapping non-conflicting operation. So what is conflicting operation? If two transactions said to be conflicting instruction if they have three conditions, right? First condition is they belong to different transaction. Second is they operate on same data item. And the third is at least one of them write operation. write operation, right? So you can see that suppose there are two transactions T1 and T2. If there is a read A, write A, then you can say that these are the conflicting instruction. If suppose there is a two transaction T1 and T2, let's take and read A and read A. So this is not a conflicting instruction. And T1 T2, if WA and WA, these are the conflicting instruction. And if T1 T2, WA and the read A, these are the conflicting instruction. So in the you can say that read A WA, write A WA, read A write A. Second is write A, and the third is write A, read A at the conflicting instruction. Okay, so now we will solve this numerical, right? So schedule S is given, read R2A, then write 1B, R3B, read 1A, write 2A, and read 3A, right? So we have to, is this conflict serializable or not? So how to solve this numerical? So there are three transactions, right? T1, T2, and the T3, right? So first is read A, right? Then another is W1B, so W1B, right? Then R3B, right? So read B, then read 1A, right? Then W2A, right? Then R3A, right? Then R3. So first we have to draw the precedent graph, right? So there are three transactions, T1, T2, and the T3. So we have to see the conflicting instruction. So you have to see the one by one. You can see first read A, read R2A. So you have to see any conflicting instruction or not. We can see that there are no conflicting instruction. Write B, there are different data item. Read B, B is the different data item. T1 is read A, but both are the right operation, right? So these are not conflicting instruction. T2, same transaction, the read A and the read A, both are the read operation, right? So these are the not conflicting instruction. Then you have to see the this write B, right? So you can see the T1 and the T3, this write B and the read B, these are the conflicting instruction. So there will be as from T1 to T3, right? So this means T1 will execute first, after that T3 will execute, right? So T3 is dependent on T1, right? So after that you have to see any conflicting instruction or not. So you can see that read A, write A, not any conflicting instruction. Then you have to see this read B, any conflicting instruction or not. Read A, there are different data item. Write A, the different data item, and this also different data item. Then you have to see this write A. You can see that read A and write A. So these are the conflicting instruction. So there will be as from T1 to T2 means T2 is dependent on T1, right? Then we have to see read A and the read A, both are the read operation, so not conflicting instruction. Then you have to see this write A, read A, right? So you can see that these are the conflicting instruction. So you can see that T3 will dependent on T2. So there will be an edge from T2 to T3. So this precedent graph is a cyclic or acyclic? Cyclic or acyclic?
Acyclic.
So this is a acyclic. So you can say that this is a conflict serializable. Everyone got it? This problem?
Yes, sir.
Sir, I did not get how conflict.
Which person you did not got?
How do you look that it is a conflict or not?
Okay. Means you have to draw this precedent graph, right?
Yeah.
Okay. So you have to three conflicting instruction. First is if there is redax or these are the data item. It can be any or wx or wx or wx or redax, right? So you can see that first we have to see read, right? We can see that we have to go one by one. We have to see right.
Yes.
So these are the different data item, right? It operate on A, operate on B. So these are the not conflicting instruction. So you can see that these are also not conflicting instruction, but you can see that these are also both read operation. So read operation are not conflicting instruction, but you can see that read A and W, but both are on same transaction. So these are not conflicting instruction. You can see that this read A and this read A also read operation. So you can see that these are not conflicting instruction, but you can see that this T1 write B. My cursor is visible, right? Hello.
Yes, it's very.
So you can see that this write B and this read B. It operate on same data item B. So these are the conflicting instructions. So you have to draw as from T1 to T3 because T3 is dependent on T1, right? So you have to draw like this. So you have to see from one by one, right? You have to see all of the below. You got it?
How T3 is dependent on T1?
You can see that read B and the write B, right?
Yes.
So it reads updated the value of T1, right?
Yeah. Okay.
So that's why you can see that T3 is dependent on T1. You got it? How to draw?
Yes.
Okay. Now we'll see the another problem. So figure 3 shows the
Sir, can we expect the similar kind of question in term?
how I can say that this all are the important topics, and if you go through practice and graded question, you can solve the entire question.
Okay, sir. One more doubts. If it is not cyclic, means it acyclic. So what we can say now?
This is a cyclic graph, right?
No, sir.
This
It's
is
cyclic.
acyclic. If it is cyclic, then we can it cannot be conflict serializable. Cannot say
Sorry, sir,
that
it
it's
is acyclic.
yeah.
Sir, if it is cyclic, then what happened?
Yeah, if it is cyclic, then we can say that these are the not conflict serializable. We cannot.
Okay, sir.
Yeah.
Okay, got it, sir.
Okay. And figure 3 shows the precedent graph of a conflict serializable schedule S. You have to see how many serial schedule are there to which S can be conflict serializable. So we have to all possible topological ordering of the above precedent graph will be the possible conflict serializable. So you can see that T2 is dependent on T1. So T1 will be first, then after that T2. Yeah.
Sorry to interrupt. Conflict serializable, understood as a process. What do you mean serializing the conflict?
Serializing conflict means?
So we saw that if it is an acyclic, means those sequence of instructions are conflict serializable, correct?
Yeah. So if it is acyclic, we can write this, right? It can be executed in the serial, right? First T1, then after the T2, after the T3, right? It can be executed serializable. Oh, did you
But it is
mention
not
what are your doubt?
happening. Yeah, that's what I was asking.
Oh, if it is not happening, right? So it cannot be executed serializable. Suppose there are let's take example T1 and T2. Suppose let's take example write A, then it also read A or write A. So you can see that T1 and T2. So T2 is depend on T1, write A and read. These are the conflicting instruction. There will be edge from T1 to T2 and T2 from T1. So this is the cyclic, right? Hello.
Yeah.
So we we cannot execute T1 serializable. T1 first T1 or then execute T2 or T2 after that T1. You have to execute concurrently. You have to first write A, then after that you have to execute T2 read A, then after that you have to execute write A. So these are the not serializable. You can say that we cannot execute in serially.
Okay, fine. Thank you.
You got it? Your doubt?
Yes, got it.
Okay.
Thank you.
Okay. Yeah, someone. Hello. Okay. So you have to see the topological ordering. You can see that T2 is dependent on T1, so T1 will be first. T3 is dependent on T2, so before T3, T2 will be. Then T3 is dependent on T1, so before T3, T2 and T1 will be execute. And T5 it depend on T3 and T4, so before T5, T4, T3 and T2, T1 will be there. So you have to see the so you can see you can a small observation. T4 can be flashed. Sorry. T4 can be placed between T1 and T2 because T4 is dependent only on T1, not T2. So you can place T1 and T2. And second is T2 and T3. And third is T3 and T5, right? T3 and T5. So let's draw the topological ordering. So you can say that T1, then T4, then T2, then T3 and T5. Sorry, T5. After that, T1, then T2, then T4, then T3, then T5, right? And there is another T1, then T2, then T3, then T4, and T5. So there are three conflict serializable. Everyone got this question?
No.
Yeah. What is your doubt?
What are we trying to achieve over here? And I mean, T1, T4.
So yeah, see, you have to give an precedent graph. You have to tell how many conflict serializable possible in this precedent graph. So you have to you can see T2 is dependent on T1. T3 also dependent on T1. So T3 after the execution of T1 and T2, T3 will be there, right? T5 is dependent on T1, T2, T3, and T4. So all so before execute T5, all the 4 transaction will be executed first. So T5 will be last, right? And you can observe that T4 can be placed between T4 is dependent on T1. So T4 can be plus this and can be this because only dependent on T1, and T4 can be plus also this T3 and T3 and T5, right? So T3 T5. So there will be three possible conflict serialization. So you have to see the precedent term and then you have to.
There is one more that is possible. T1.
Yeah. Okay.
It
T1.
Can do T3 also, right?
T1, then after that?
T3.
Okay, after that?
So what is this? I mean, I'm trying to understand. There are two arrows, right? To go to T3, there is T1 to T2 and T2 to T3. One way.
Okay, let me erase. So after that.
So one is T1 to T2.
T1 to T2.
And
after that
T3.
T2 to T3.
Yeah, and then maybe in the next row, please write next row.
Yeah, next row.
T1.
So yeah, you have to tell T4, T5 also, right?
No, I mean, I'm just first trying to understand the doubt between T1, T2, and T3.
Okay, see, this arrow means T2 is dependent on T1, right? These are
T1,
the two conflicting instructions. So before, T1 will execute first. After that, T2 will be execute, right? So
yes,
before T2, T1 will be execute, right? So that's why means.
Yeah. No. So what I'm saying is please write T1 to T3 is also possible, right? We can write T1 to T3.
Okay. Then after that.
Okay. Not possible because then we will not be able to do T2, right?
Yes.
So
that is the thing.
T1 to T3 we cannot go because that T3 is dependent on T2, right? So there is incoming arrow is coming to transaction T3, right?
Okay.
Yeah. So you
That's
have
why that is not possible.
How many incoming arrows are coming to that transaction? Like on T3 there are two incoming arrows, right? From T2 also and T1 also, right? So directly you cannot go to T3. I think first we have to go to.
Hello, sir.
Hello. Yes.
Sir, option 2, then how you are going to T1 to T2 and T2 to T4?
In which?
There is no connection between T1 and T2, T2 and T4?
Yeah, there is.
Just remember again.
See, suppose there are 5 transactions, right? T1, T2, T3, and T4 and T5. So it may be possible there is no conflicting instruction between T2 and T4, right? So you can place between anywhere else, between T1 and T2, T2 and T3. So before T4 execution of T4 before you have to execute T1. Then after that you have to execute T2. So before T1 will execute first, after that T4 will execute. You can see that in every possible T1 is execute first, after that T4 will
Can you
execute.
explain the second option? I think whatever you written in the second option here.
Okay, in this option.
Yes, sir. Yes, sir.
Okay, you can see that. Okay, let me erase. You can see that T1 is dependent on T2, right? So T2 is dependent on T1. So T1 and T2. Then after that, T4 is dependent on T1. We can place right T4, right?
Yes, sir.
T4. You can see that T3 is dependent on T2 and T1, right? So it will execute first T1 and T2. So yes, it is executed first T1 and T2. So T3. You can see that T4, T5 is dependent on all the transactions, right? So all the 4 transaction is executed. So after that, T5 will be executed. So you have to see the topological sorting. You can go through it, right?
Yes.
Okay.
Okay.
So, okay, everyone got this?
Yes.
Okay. So we'll see. This is the important question. So I will wait 1 minute. You can solve first. After that, I will solve. You can answer in the Zoom chat box. Okay, so let me solve. Consider the following schedule S with 3 transactions T1, T2, and T3 given schedule. What is the possible numbers of conflict serializable schedule of the above schedule? You have to tell the possible numbers of conflict serializable, right? So you have to see the first you have to draw the precedent graph, right? So that's T1, then T2, then T3, right? First is read to, after that write, after that write 1A, after that read B, right? After that R3B, after that W3B, right? So let's draw the precedent graph, right? So T1, T2, and the T3. So you can see that you have to see the conflicting instruction. So read A, we can see that T1, read A, write A. So T1 is dependent on T1, T2. So there will be as from T2 to T1, then write A. So only T1 is dependent on T2. Then there are different data items, right? Then
So Bindu, sorry, the second line, I mean, it's a very obvious question. The second line, WA, right?
Yeah.
So you're saying
Yeah.
T2, read and then write.
Yeah.
The
T2
that we are following, but we will consider that it is okay, right? Read A and write A.
Yeah, it can be, first can be right, then after that it can
Fine.
be right. Yeah.
Okay, now just in case, I mean, I'm taking a hypothetical scenario instead of W2A, the second item.
Yeah, yeah.
Just in case there is again written R2A.
There is again written R2A. There can be, there will be read A after that.
No. In WA is not written.
Yeah.
The second item is R2A.
Yeah, means instead of W2A, it can be written R2A, right?
Yeah, just a hypothetical scenario.
Oh, it can be, it will read twice, right? So first
it will read twice. Okay.
Yeah, twice.
And it is okay. I mean, it can read twice.
It is okay.
Not a problem.
It is tribal, right? So it means not read twice. It is not beneficial.
No, that is what I was saying hypothetically, but okay.
Yeah.
Got it. Thank you.
Sorry. Then you can see that read A. So these are the different data items. So there are non-conflicting instruction. Now we can see that read B and the write B. So these are the conflicting instruction. There will be edge from T2 to T3, right? So T3 is dependent on T2, right? So you have to see the numbers of conflict serializable. So you have to you have to see the topological sorting, right? Topological sorting. So you can see that. So T2 will execute first because T2 is T1 is dependent on T2 and T3 also dependent on T2. So T2 will execute first. After that, it can be T3 or T1, right? So it can be T3 or another one will be T2, T1, and T3, right? So there are two possible two conflict serializable. Everyone got this question? How to solve this types of numerical? First, we have to draw the precedent graph. After that, you have to do the topological sorting. Please remember. Hello, everyone got?
Yes, sir.
Okay.
Sir, I have a doubt, sir.
Okay.
Sir, how can you put an arrow mark because it is not conflicting, right? T3 to T1. How can you draw an arrow mark there?
Okay. This T1, which arrow? This arrow or this arrow? This arrow or this arrow?
No. You write in the sentence, right? T2 to T3, right? To T1. In the first sentence.
This.
Yes.
Okay. See, there can be. You can see that. You have to see the conflict numbers of possible conflict serializable, right? So you have to see. You can see that T2 is dependent on T1 is dependent on T2 also, and T3 is dependent on T2 also, right? So first T2 will execute it. After that, it can be execute T3 or T1. It can be anything. So it can be execute T3 also or T1 also. So these are the you can just understand the first T2 will execute, after that T3 will execute, after that T1 will execute. We have to find the numbers of possible conflict serializable. So you can see, and there can be one possible T2 will execute first, after that T1, after that it can be T3. There are two possible, right? So that's why you have to see the topological sorting. Nothing else.
Yeah. Subhendu, yeah. Everyone know how to find the topological sorting, right? Yes or no?
Yes.
I had a doubt with the first question.
In the first question, Subhendu, can you scroll up that question? Please explain.
Already, yeah. Okay.
I think it got erased.
Yeah, it is. This question.
No, the one before this.
Hello.
Before this one.
This question.
Yes.
Okay. Let me solve.
No, I mean, if you want, we can just talk about the topological sorting for this. You had T1 pointing to T2 and T2 to T3.
Okay.
And T2 to T3 and T1 to T3.
Okay. T2 to T3, right?
Yes, correct.
So you can see that T3 is dependent on T1 and T2 both, right? So T3 will be last, right? You can see that T2 is dependent on T1, right? So T2 is dependent on T1. So yeah.
Subhendu, hello.
Yeah.
Yeah, Subhendu. So who asked that question? Bharat, right?
Yes,
so
please.
yeah, Bharat. So how to find the topological order? So first you have to check whichever the node which do not has the any incoming is. So you can you tell me which the node have not no any incoming is? First one, that is T1, right? Hello. So you can see T1 do not have any incoming edge. Incoming edge means arrow, not coming an arrow, right? Hello.
Yes, I can hear you.
Yeah. So Bendu, then you can write the T1, right? Yeah, right, T1. Then erase T1. Then simply erase T1. Yeah, you can remove it. Just remove it. Just remove everything. Yeah. So then check for the next one, T1 and T2, and then you have to again check whichever which node do not have any incoming edge. That is T2, right?
Got it. That's also a question. I want to ask if T1, T3, T2 is possible, but I understand. Incoming rays is what will come next.
Yeah. So that is the order in this phase. I hope it is clear, right?
Yeah, it is clear, everyone.
Yes, sir.
Okay. Now we'll see a recoverable serial. So we'll see with the help of examples. Suppose there are one schedule and two transactions, T1 and T2, and read a right A, and T2 transaction after that in here read A and the write A, and the commit operation happen, and after that commit. So you can see that T2 is dependent on T1 because T2 reads the operation update the value of T1. So is this a recoverable schedule or not? If so, you can see that if in this position transaction failure, right? So in this position transaction is failure, right? So you can see that we can recover T2, right? But we cannot recover T1 because sorry, it's a small mistake. Suppose sorry, this is commit operation, and after that so commit operation, and after that commit operation. So if transaction failure in this one, right? If in this one transaction is failure, so we can recover T1 transaction, right? But we cannot recover T2 transaction because commit operation is already happened. So you can say that this is not a recoverable schedule, right? Let's take another example. Suppose T1 and T2.
Sorry, you said that T2 is not recoverable, right?
Yeah.
Commit has happened before the transaction has failed. That is not recoverable. T2.
Yeah, because you can see that read A, you can see suppose T1 and T2, there is a read A, write A, and T2 is updated the value of T1, right? After the write A, T2 is read, right? So then write A. So if this is commit after the so
shall I explain? Commit has happened, right? Commit has happened for T2.
Yeah, commit has happened T2,
and there is a new value for the
yeah. Suppose in this position transaction is failure, right?
Yes.
So we can recover T1, right? Because T1 is not committed yet, but T2 is committed because T2 is reading the value of T1, right? After updated the value of T1, so we cannot recover this. So we cannot say that this is a recoverable schedule. Yeah, someone is explaining something.
So the thing is, since T2 is copying its value from T1, so T1 is the one that is updating on attribute A, value A, and T2 is copying its value from T1. So since the failure has occurred after the commit of T2, now T1's value has been rolled back. It has undone all the changes. Now, but T2 has copied its value from T1. Now there is an inconsistency.
So Apple, you got it? Hello?
No, exactly. I didn't.
Okay, let's take
recovery.
Okay, let's take one example. You will got it.
Okay.
Suppose a value is suppose 1, right? So reading the value of 1, right here. So A equal to A plus 1, right? So A will be 2, right? A will be 2, and
Yes.
reading the value of 2. You'll suppose
2 plus 1 again.
2 plus 1 equal to 3. Okay. So already happened in committed. So if it's committed, then A equal to 3, right?
Yes.
So if transaction is failure in this one, right? So we can recover this, but we cannot recover. Initially A value is 1, right? So we cannot recover A is equal to 3. Okay, let's take one example, another example.
No, what do you mean recovering? What I'm just
Yeah.
struggling with the word recovering. What exactly you mean by recovering?
Oh, okay. Suppose there are two bank account T1 and T2. So A balance is right. So okay.
Hello.
Yeah.
Subhendu. Yeah. So yeah, Apul. Is it? Yeah.
Yes.
So, yeah. Suppose the data is present. A is present in the database, right? So yeah. And that data is bringing to the local buffer, that is the main memory, right? So we reading the both value from the main memory, that is the A. Suppose Subhendu, can you write the database value A equal to 100? Yeah, database just simply writes the database one side and one is the main memory value. Okay. Can you stop sharing for a moment? Is it visible, right? Yeah. Hello.
Yes.
Hello.
Yes.
Yeah. So suppose this is your database, right? And A value equal to 100, right? And this is your main memory, right? So for the data read by the any operating system or anything, so first it need to bring in the main memory, right? So A value is 100, right? And so what is your transaction? That is T1 and T2. Okay. And first this is read operation A, and that is write operation A, and also read operation A, write A, then commit, right? Hello. Yeah. So in this point, if failure occurred, then what will happen, right? That is the question, right? So first A will reads the value from the main memory, right? So we reads the value A equal to 100. Apul, are you getting it? Yes. Then it's changed the value right to 200.
Yes.
Yeah. So if we change the value to 200, then also we change the main memory value also.
Yes.
That is 200, right? And suppose this particular transaction P2 came and also reads the value. So it will read the value that is present in the main memory. So now it reads the value is 200, right? And suppose if this particular write operation is a performed, let's say it want to withdraw. So suppose let's check this is the 200 rupees. So it's a 200 rupees and want to withdraw money, right? So suppose it withdraw 150 rupees. So what is the actual value written into the database? That is the 50, right? So that is the original value. And after that, the commit operation happened. If commit operation happened, then it will reflect in the database.
Yes.
So then we will change the value into the database, right?
Yes. Right.
Now you can see the whole schedule, the whole operation or the schedules, the failure occurred. So what happens if any failure occurred, then it should be rollback, right?
Correct.
Right here you can see, is this rollback, is it happened rollback? Because it actually it changed the value in the database, original database,
Right.
because of the commit one. So we can change this value, right? But we cannot change this transaction value. So actually, if this will not there, so what is recoverable schedule? If some T1 is read, T2 reads some updated value from T2 reads some updated value that is updated by different transaction on the data item. So that's the commit transaction should be appear before that. So that is, so if commit is happened first T1 and then T2, then you can say this is a simple, this is rollback schedule, right? So first, if
the last statement is not visible, it's coming below the bar.
So
you can press the Alt button. You can press the Alt button to hide that bar.
So yeah. So after this, you can simply think. So after this is the first commit operation of T1 appear, then commit operation of the T2 will come in the recoverable schedule, because this particular transaction reads the value that is modified by the T1, right? So this type of, this is we calls the recoverable schedule, right?
Okay, fine.
And what Subhendu is saying, so that is if any transaction come and commit before that transaction, but actually it reads the value of T1, updated value of the T1. So that why that is not recoverable schedule.
Okay. Okay, fine, got it.
Yeah. Okay, thank you. Yes, Bendu, you can.
Yeah, thanks. Okay. So everyone got it, recoverable schedule. Okay. Let's see another example. So T1 and T2. Okay. Read A, write A, then another read A, and the write A. This commit happen after the commit of transaction T1, C2, transaction T2 is committed, right? So is this a recoverable schedule? So yeah, I can say that this is a recoverable schedule. So now second question is this cascadeless schedule? We can see that if in this position, if transaction failure occur, right? In this position, right? So because of one transaction is failure, because of you have to roll back T2 also and T1 also. So we cannot say that this is a cascadeless schedule. We can say this is a cascading rollback, right? So because of one transaction is failure, we have to roll back all the transaction, right? So if this position, the transaction is failure occur, we have to roll back T2 also and T1 also. That's why you cannot say that this is a cascadeless schedule. Let's take another example. T1 and T2. Read A, write A. This is commit happen. After the commit, write A and redo, and this commit, right? So you can see that this is also a recoverable schedule, and this is a cascadeless schedule. We can say that if any you can if this position transaction is failure, we have to roll back only T2, right? We have not, because only T1 is already committed, so you don't have to roll back T1. We can see that we can say that this is a cascadeless schedule. So everyone got his cascadeless schedule and recoverable schedule. Hello.
Can you repeat?
Cascadeless schedule and recoverable schedule.
You're asking the difference?
Means you got it. What is cascadeless schedule and what is recoverable schedule?
So recoverable schedules are, schedules that can be recovered without having to encounter inconsistency, and cascade.
Less.
To tell about cascadeless, I'll first tell what cascade schedule is. So once something goes wrong, we have to do a continuous rollback. So since T2 is copying from T1, first T1 will roll back, and then copying its value, T2 will roll back. So that continuous rollback is called cascade schedule. So to cascadeless schedule is avoiding that continuous rollbacks. So in order to do that, we will commit once the writing has been done. So right after writing A in transaction 1, commit will be done. And right after writing A in transaction 2, committing will be done. This will lead to cascadeless.
Yeah. Okay.
So sir, if a schedule commits immediately after it's completed, then only the schedule will be cascadeless.
Yes. Okay. So next is two-phase locking, right? So why is two-phase locking? To achieve conflict serializability, right? So a transaction is said to be two-phase locking if it is transaction follow unlocking and locking can be done in two phases: growing phase and shrinking phase, right? Then we can say that transaction follow two-phase locking. So let's take example. So suppose there are two transactions T1 and T2. Okay. So exclusive lock XA, then write A, then unlock A, and T2 also write the value of A, exclusive lock A, then write A, then again T1 read the value of A, right? So say unlock A, then read A. So is this transaction follow two-phase locking? We can see that this is the growing phase, this is the shrinking phase, again growing phase, right? So you can say that this transaction does not flow two-phase locking protocol. Let's see another example. There are two transactions T1 and T2. Okay. T1 suppose exclusive lock A, then read A, write A, then unlock, right? Unlock. And T2 exclusive lock of B and also exclusive lock of A, right? We can say that read A and write B. So this transaction, this schedule is follow two-phase locking protocol or not. You can see that this is the growing phase, right? And this is the shrinking phase. In transaction T2, this is the growing phase. So unlock A, unlock B, and this is the shrinking phase. So you can see that locking and unlocking can be done in two phases: growing phase and the shrinking phase. Transaction T2 growing phase and the shrinking phase, right? So you can say that this schedule is follow two-phase locking protocol. So everyone got it two-phase locking.
Do you mind taking up growing phase and shrinking phase, or if it is too much, then can you just tell which live session to refer?
Yeah, so growing phase means a transaction can obtain lock, but it cannot be release lock. We can see that in growing phase, transaction only obtain lock, right? Cannot be release lock. And in sinking phase, a transaction can release lock. You can see that in sinking phase, transaction release lock. And you can see that in transaction T2, in growing phase, transaction can obtain only lock. So you can see that exclusive lock of B and exclusive lock A is obtain a lock, and in sinking phase it can release a lock. That's
What have you written?
you means unlock.
Unlock. I have.
Yeah. So
Okay.
everyone got it? Okay.
Sir.
Yeah.
Sir, suppose in after T2 unlocks B,
Yeah.
T1 again asks for a lock. So will it be a two-phase lock or not?
Yeah, T1 is suppose lock.
Yes.
Exclusive lock of A, right?
Yes. If it again asks for a lock, then
yeah. Okay.
Then it
we
will
can see that.
two-phase.
Yeah, I'm explaining. You can see that again growing phase, right?
Yes, sir.
So it cannot be done means in two ways: growing phase or sinking phase. Growing phase, then again sinking phase, then again growing phase. So it cannot be two-phase locking.
So it's also there is only one growing phase and
Yeah.
sinking phase.
Yeah, only one growing for transaction T1 and transaction T2 also.
Okay, so
you have to locking and unlocking can be done in two way: growing phase and the shrinking phase. So everyone got his two-phase locking, because these are the importance for n-term also. And if you have any doubt, you can refer to week 10 open session in locking. I have explained in very detailed way.
Sir, could you tell the advantages of 2PL?
Yeah, first advantage is two-phase locking. Always two-phase locking. Always 2PL are conflict serializable. To achieve conflict serializable, we are using concept called two-phase locking. This is the main advantage. Okay, so we'll move to the next point.
And there are no deadlocks to it.
Yeah, there is a problem deadlock. In two-phase locking can be deadlock.
Okay.
You can watch week 10 open session. I explained how deadlock occurs. We can see that. Then we'll see strict two-phase locking protocol, right? So first is follow 2PL, and all exclusive lock should unlock after commit operation. So let's understand with the help of example T1 and T2, right? So log XA and also log right shall log B. So write A, read B, right? Then commit, then unlock A, right? Suppose unlock B and transaction T2 lock shall log B, read B, unlock B, right? So is this transaction follow strict to PL not? So you can see that follow to PL plus all exclusive lock should unlock after commit operation. So first we have to see the it is follow two phase locking protocol or not. We can see that this is the growing phase and this is the shrinking phase, right? In transaction T1 and transaction T2, this is the growing phase and this is the shrinking phase. So you can say that this is followed two phase locking protocol. And the second point is all exclusive lock should unlock after commit operation. So you can say transaction T1 exclusive lock on data item A. So it unlock after the commit operation of A. After the commit operation, so you can see that it unlock after the commit operation only exclusive lock, right? So you can say that this is a strict to PL. So everyone got it strict to PL?
Yes, sir.
Am I audible, right?
Yes, sir.
Okay, okay. Let's give another example. You will got it. So, let's take an only one transaction, right? So there is a lock, exclusive lock of A, and right. So you have to see all exclusive lock should unlock after commit operation. So it should be unlock after commit operation. Then we can say that this is the strict to PL, right? Okay. Then okay. Let's see another example. Then there is a so let's take another example. T1 and T2. Exclusive lock of B and share lock of A, right? Okay, so write B, read A, then unlock A, commit, unlock B, then lock exclusive lock of A, then write A, unlock A, and commit. So is this follow stick to PL or not?
No, sir.
No.
Why? Anyone?
So it follows A. Like it unlocks A before, and the T1 unlocks A before committing.
So it is follow stick to PL or not?
No.
So you can see that first we have to see the 2PL follow 2PL or not. So you can see that this is the growing phase and this is the shrinking phase, right? And this is the growing phase and this is the shrinking phase. So you can see that this transaction follow two-phase locking protocol. Then we have to see the stick tuple. So what stick tuple said? All exclusive lock should unlock after commit operation. You can see that there is a exclusive lock P. So in transaction T1, it unlock after the commit operation. So transaction T1 follow, but transaction T2, you can see that before the commit it unlock a. So you can see that this is not stick tuple, right? So everyone got it, stick tuple. Hello.
Yes, sir.
No, for this we are saying that it follows 2PL both.
Yeah.
But it does not follow.
Yeah. So see,
it does not follow strict 2PL.
Yeah, it does not follow stick 2PL. Follow what stick 2PL said? Follow 2PL plus all exclusive lock.
Should happen after commit.
Should unlock after commit operation.
And we will say this for together T1 and T2. We will.
Yeah, both.
T1 follows strict 2PL, correct?
Yeah, but T2 does not flow. Then we can say if any transaction does not flow, then we can see that this schedule does not follow strict 2PL.
Okay, fine.
Then we'll see rigorous two-phase locking protocol. So what happened? It follow two-phase locking protocol. It's short form, and also follow all locks. It can be either exclusive or share lock, right? Should unlock after commit operation. Right? So what rigorous two-phase locking protocol said? It follow two-phase locking protocol plus all locks. It can be exclusive lock or it can be share lock. It should unlock after commit operation. So suppose this unlock after that. So is this follow rigorous 2PL? Anyone?
Yes, it follows rigorous.
No, sir.
Yeah. So Apul, can you say
No,
that?
yeah. It doesn't follow because for T1 UA is before commit.
Yeah, you got it. Okay.
Yeah.
So suppose transaction T1 lock exclusive of lock A. So there is a share lock, write A, read B. So it unlock after the commit operation, all the locks, right? So after the commit, we can unlock A and B. So everyone got it? Two-phase locking protocol, because these are the importance for runtime also, and theory means you can. These are the important topic also, right? And it's S2PL, stick two-phase protocol locking protocol, and rigorous 2PL. Everyone got it?
Yeah, sir. Just one question: what's the advantage of R2PL over S2PL?
Okay. There are no such advantages.
Okay.
Yeah. Okay. So now we'll move to the week 11. So if anyone have any doubt in week 10, you can ask. Otherwise, we'll move to the week 11.
I just want to summarize it once. So there are two phases. One is a growing phase. The other one is shrinking phase. In the growing phase, you can either obtain lock or upgrade from shared to exclusive lock. In the shrinking phase, you can lose the lock, unlock, make an unlock, or you can downgrade from an exclusive lock to shared lock, right?
Yeah.
And the strict two-phase locking is you do not unlock until the commit is done. Is that right?
Yeah. In strict TPL, that means exclusive lock should unlock after the commit operation. Okay.
All right, sir. Thank you.
Okay.
Sir, from week 10, I had one question.
Okay. Please tell me.
Sir, when we are testing for view serializability and the schedule is not conflict serializable and it has blind writes. Okay.
Yeah.
Then we have to test for view serializability also.
Yeah. So you have to see the. Okay. Let me erase. You have to see the three conditions. First condition. Means if suppose there are transaction T1 and T2 and the T3, right? So
Sir, the doubt is I'm not understanding why we are testing for view serializability then.
Okay, view serializability is because of it may be serial schedule, right? Okay. Let me. This is the conflict serializability. Conflict serializability. It always is the serial schedule. After that, it can be, if it is not conflict serializable, it can be also serial schedule, right? So if it is view serializable, then you can say that we can say that there is a serial schedule possible. That's why you are testing view serializable.
Sir, but the condition which says that if we have blind writes, then it will be view serializable.
Yeah, if it is a blind write, then it will be view serializable.
Then we do not have to test for view serializability.
Yeah, you have to test view serializable also, right? If it can be, if it is blind write, it can be or it may be or may not be, right?
That is the point I'm not getting.
Yeah, it may be or it may not be.
Okay, sir.
Okay. Okay. Okay, let me give you another question. Suppose there are in a schedule 2 transactions. There is a schedule S and there are T1 and T2, right? And both are the okay, let me write the schedule S, read A, then write A, then R1, right? Then R2B and W2B, right? So you have to tell the how many serial schedule possible, right? We can see that read A, then write A, then read B and the write B, right? You can see that both are the independent transaction. None of the transaction is means conflicting transaction, right? If you draw the precedent graph, what will be there? T1 and T2. There will no as because T2 is not dependent on T1 also, T1 and T1 also not dependent on T2. Then you have to say how many serial schedule possible. Anyone? Maximum number, how many serial schedule is possible for this schedule?
2.
Okay. Yeah, T1 and T2, right? It can be T1, T2 or T2, T1. Okay. And let's take another example. And T3 and read C and WC. If you draw the precedent graph, then there will be no conflicting instruction, right? So in this case, how many serial schedule is possible?
6. I'm not sure. Means you can take the T1, T2, T3, T.
Yeah.
In any order you can take, no?
Yeah, you can any arrangement. There will be 3 factorial, right?
Yeah, 3 factorial, 6 it.
Okay, yeah. Everyone got this question? Okay. So we'll move to the next week 11. So we have to tell the which transaction to be undone, which transaction need to be redone, and which transaction to be ignored, right? So we can see that any transaction that committed before the checkpoint, we can see that T1 is committed before the checkpoint, right? So then T1 can be ignored. Right. Then another is any transaction that committed since the last checkpoint need to be written, right? This is system failure occurs. So we can say this transaction is committed and this transaction also is committed, right? So this T2 and T3 will be redone, right? With T2 and T3 will be redone. We can see that T4 is started but not committed yet. So T4 will be undone. So everyone got it? Hello?
Yes, sir.
Okay, let me write another. Suppose this is a checkpoint. T1, T2, T3, T4 and T5. Can you say that which will be the ignored and which will be the redone and which will be the undone?
T1, T2,
T1 and T2 will be ignored, right?
T3 will be done.
T3 will be redone.
T4 and T5 will be undone.
Yeah. Everyone got this? Hello?
Yes, sir.
Okay. Okay, now we'll see the immediate database modification. Right? So in immediate database modification scheme allows update and often uncommitted transactions to be made to the disk or buffer before the transaction commit, right? So you can see that T0 is started. This is the old value and this is the new value, right? And so after the before this, if this position transaction is failure occur, can you say which transaction need to be redone and which transaction need to be undone in immediate database modification?
So just repeat the definition what you said in the beginning.
Okay, immediate database database modification means before the transaction committed, you can see that. So suppose, okay, let's say this is the database. This is the old value, right? 1000, 1000 and 2000, right? So before the committed, this will be the 950, right? Before the committed, it will happen in immediate, right? Before the committed, it will write the disk itself. So if you go T0 start, then T0 A 1000 to 950, 1000 to 950, it will be, it is A value, right? And B value. So A will be 950 and B will be the 2050 before the committed, right? And T1 start. So C value will be 60, right? Before it is not committed yet, but C will be 600. So you got it, Apul?
Yes. Okay. Fine.
Okay. So if in this position transaction is failure occur, right? After the this position, can you tell which will be the redone and which will be the undone?
So C will be redone.
Redone.
T1 will be
T1. Okay, you can see that T0 is started and T0 is committed, right?
Committed, right?
So it is committed, then it will be T0 will be reader.
Okay.
Yeah, it will be redone. And T1 is started. In immediate, I am telling immediate database modification, but T1 is started, but T1 is not committed, then T1 will be undone.
The T0 has committed. Why should it be redone?
T0 is committed, so that will be redone, right? So redone means I return the new value, right? So new value, return means new. Undone means it return to the old value.
Okay.
When will it be ignored? We also,
if it is at checkpoint, then it can be ignored, right?
Okay.
So it's not.
So can you repeat that point again? Checkpoint.
Yeah, if it is checkpoint, then it will be ignored. If it is not checkpoint, then it will be returned. You can see that in the above example, T3 will be returned, right?
Okay.
If this is the checkpoint, right? If it is a checkpoint, then it can be ignored.
And checkpoint is different from commit, right?
Yeah.
Is checkpoint different from commit? Checkpoint. What is the concept of checkpoint?
Checkpoint means
what is happening in checkpoint?
Yeah. So if a transaction got failed, so it will roll backward towards the checkpoint, right? So it will update, we will redo and undone the value of all the transactions till the checkpoints. After that, like before that, it will ignore all the transactions. So checkpoints, like it will our transaction will roll back to that particular point.
Yeah, yes, sir. Yeah, you can think checkpoint like the milestone. So up to this, you have to roll back. Hello.
Yeah. Okay.
Yeah. So you have to see every in this any transaction is a commit happened or not. That condition just Subhendu had mentioned that you have to take care.
Okay. So what we are seeing right now, for example, the code T0 start. So similarly, it would be written over here something like a checkpoint, right?
Yeah.
Okay.
So here I think checkpoint is not there. In the this log in checkpoint is not there.
Not there.
You can think start of the starting first instruction. So before that, there is a checkpoint.
Checkpoint. Then in that scenario, we can ignore T0.
T0. Not got you.
If checkpoint is before T1 start.
If this, yeah, that then we can ignore
T0.
Okay. Yeah, then you can.
Yeah. Okay.
So you can think about that checkpoint means the checkpoint mark the position till where the consistency of the transaction is maintained. You can see, there is a checkpoint, right? So you can think about this up to this point, consistency is maintained. Consistency of the database is maintained. You can think about this also. Hello?
Sir, checkpoint means that all the items from the buffer are written to the disk.
No, that is commit operation. When commit operation appears, then it will reflect to your database. So checkpoint is simple. You can think like up to this, you have to roll back. So if there is no any checkpoints, then you have to roll back all the work that you have done, right? That also you need to be undone, right? So that is kind of waste of time, also waste of work also you. So you can, if any failure works, any failure occur, then you can roll back up to the latest checkpoint up to that. Is
okay.
Yeah.
So so you got it. Immediate database modification. Hello. Hello, am I audible?
Yes, Subhendu.
Okay. So now we'll see the default database modification. So what do we mean by default database modification? After the commit operation, database will return to the main memory to the disk, right? So you can see that A0 is changed to 100 to 950, right? T0 and B is changed to 250. So it will be the in main memory, right? It will be the main memory or buffer. After the commit operation, suppose this is the database 1000 and A equal to 1000 and B equal to 2000. So after the commit operation, A will be 950 and B will be 2050. In immediate before the commit operation is 950 and 250, but in the default database modification after the commit operation. This is the difference. Hello, everyone got it? Default database modification.
What is the difference between both the databases? I don't understand.
Yeah. In immediate database modification, T equal to T0 A, this is available, right? 1000 to 950. So in immediate, it immediately return to the database or disk itself 1000 to 950. But in immediate, in default database modification, after the commit operation, it will return to the A950. This is the difference.
So, but according to this question, the answer won't change, right? Because there is no checkpoint. So it should roll back the same. The answer will be same besides what the database is using, right?
Yeah. Okay. Yeah.
So does that mean that if we modify before the commit again one more time, like 1050, then we are making 950 to 975, and if we are committing after that, that means that intermediate one transaction will not get returned into the disk. That is what it is.
And see, so okay, let's see. So first immediate database modification. What happened? T0A, this is the database, right? And this is the main memory or buffer. So in immediate, what will happen? T0A 1000 to 950. In immediate, it will directly return to the means after the before the commit operation does not commit, it will A will be 950. After the T0V 2000 to 250, so it will be 2050. before
So
the commit operation.
what makes it write immediately? We understand commit makes something write from main memory to database.
Yeah.
You are saying immediate. What is it that immediately writes?
Means on the disk itself, it will return in the immediate database.
I think what he's trying to say is, in before database, the things from the main memory will be saved to database, main database, only in the commit statement. But in the immediate database, right after it's changing in the main memory itself, it will be automatically updated to the main database. So without having to commit it manually. I think that's what he's trying to say. Is that?
Yeah.
Okay. So, sir, but
So what I'm trying to understand, is there something that will, for example, if we just see this log, we cannot tell looking at this log whether it's an immediate or whether it's deferred, right?
So yeah, it will be written on the question. It will be immediate or it will be deferred database modification. Okay, so don't worry.
And from the language perspective, is there some statement that you use to write immediately and commit?
Yeah,
Leave it,
it
that's
will
fine.
be.
I mean, if
It will be directly written. This is the immediate database modification scheme, and this will be the deferred database.
deferred. Okay, fine.
Sir, so in this case, we undo T0 and redo. I'm sorry, we redo T0 and we undo T1. Is that right?
In deferred modification scheme, you have to see T0 is committed, so T0 will be written, right? And T0 T1 is not committed, right?
Yeah.
T1 is not committed, so it will return to the old value 7. It's not.
Okay.
It will return to the old value 7.
Okay.
0. Okay.
And sir, if the crash occurs immediately after T0 commits, then also it will be the same.
It will, if it is T0 committed, then T0 will be written. Okay.
And what will happen to T1? What did you say? Will it be like?
It will be like to the old value, right? So 700.
Yeah, it will.
It will be written to the.
Sir, T1 wouldn't have started it out.
Yeah. So it will be rollback, right? T1 will be rollback.
Sir, I have one dilemma. The thing is, in this particular question, besides what kind of database is using, maybe it's immediate or deferred. The number of things that will be undone or redone are same, isn't it?
No. In immediate database modification, will use redone or undone, right?
Okay.
But in deferred database scheme, we use T0 will be written, right?
Yes.
And T1 will be does not committed, so T1 will be rollback.
Okay, so it will be undone.
Yeah. Like
okay, so in what you are saying is in case of a deferred database.
Yeah,
so
this is
immediate,
this is the deferred. In immediate will be
both of them will be redone.
Yeah, T0 will be redone and T1 will be undone. In immediate.
When the failure happens after the last.
Yeah, after the last. If this is the failure. So everyone got immediate and deferred database.
I don't understand the difference between I know what undone or redone is, but how is this different from rollback?
Rollback means it will be.
So, hello, am I audible?
Yes.
Right?
Yes, sir. Yes.
Yeah. So, in what happens in the deferred data modification and immediate data modification, as I previously explained. So first, we modify the data item into the local buffer, that is the main memory, right?
Yes.
Yeah. So that is deferred modification. What happens? We first change the data item into the local buffer. Then if any commit occur, then only that change reflect in the database, right?
Okay.
That
Okay.
is the concept of the deferred data modification. So
Yes.
in that case, whatever changes we have done in the local buffer, right? So
Okay.
if any failure occurred and commit operation does not, there is no commit operation, so we can simply ignore that part, right?
Yes. Yes.
Am I clear up to this point? In
Yes,
deferred,
sir.
I'm explicitly talking about the deferred data modification. So
Okay.
if suppose T1 start in the deferred data modification, T1 start and it does not have any commit operation, right? So we can simply ignore that, right? But here you can see T0, there is commit operation also is there. So that should be need to be reflect in the database. So that's why we do redo operation in the deferred data database modification, right?
Okay. Okay.
Okay. So here you can see there is lot of work. First, you have to change in the local data main memory. Then it will reflect in the database, right? So what we do in the immediate database modification, instead of changing in the main memory, we directly change that change into the our database, right?
Okay.
If any changes, if there is no any commit operation for that particular transaction, suppose T1, you can see T1 does not have any commit operation. That's why in immediate data modification, we need to be undo the operation. But since the T0, you can see the commit operation. That's why we need to do redo operation in the immediate database modification. And
Sir,
someone,
yes, no, I understand that. I understand why we are doing read on and undone. But how is rollback different from undoing things? I mean, rollback is just a meaning of undoing, isn't it?
yeah, that is exactly the same thing. I think he mean that is ignore part. In deferred data modification, that is simply ignore. You can ignore transaction. You already. Hello, is it clear to everyone? And someone asked why in the immediate data modification commit operation is required, right? So that changes in the database need to be permanent, right? So that's why commit operation. Is it clear? Hello.
No, actually, there is now confusion. What Subendu explained, immediate writes to database.
Yeah.
What you are saying, commit makes the commit statement
that
it also
change
makes
need
it
to be
write to
permanent.
database.
Yeah, I am exactly the same thing.
Permanent. Okay.
Changes in the database, and if commit operation occurred, then that change is the permanent, right? No need to undo. Are you
okay? Fine. Yeah. Okay.
Okay, everyone got this clear? Immediate and deferred. Okay, we'll move to the next question. So this is the from practice assignment question, read question, right? So answer questions. Yeah, this on the given data. A RAID 5 storage system with a similar arrangement of priority block as described. Size 15.16 is used for the storing the following data. So according to the figure, this 2 has crashed. What data is present in 2 block? You have to tell the what are the data is present in 2 block. So in RAID 5, we uses XOR recovery, XOR operation for recovery to facilitate for lost data. So the data stored in a block of disk 2 can be obtained by perform bitwise XOR operation, right? So you have to perform XOR operation. So 0, 1, 0, 0, right? So you have to perform 0, 1, 0, 0 into XOR, right? 0, 1, 0, 0. right? Then jar 0001 0001 and jar 0101, right? So if you solve, then you will get 0100. So everyone got how to perform jar operation. So let me give one example. 0100. So suppose there are two values A, B, XOR 00, 01, 10 and 11, right? In jar operation, 00 is 0, 01 is 1, 10 is 1 and 11 will be 0. If there is odd number of 1, then it will be 1. You can see that in this position odd number of 1, so it will be 1. You can see that there are only 1, so it can be odd number of 1 will be 1, other than it will be 0, right? So let's perform one by one. 0 1 0 0, it will perform 0 1 0 0, right? 0 1 0 0, so it will be 0 0, then it will be also 0 and 0. Then you have to perform jar operation of with this 0 0 0 1. So then will be 1 0 0 0, right? Then you have to perform operation of jar with this 0 1 0 1, right? So it will be 1 0, then 0 1 0 0. So this will be 0 1 0 0. Everyone got this?
No, what are we doing?
Okay, see, Dix2 has crashed, right? So this is the red 5 storage system. So this Dix2 has crashed, so you have to recover, right? So for recover red 5, we uses jar, right? jar operation, right? So you have to, if it is any of the disks recover, we uses jar operation. So you have to, if this disk gets crashed, right? So you have to perform jar operation all the disks, disk1, disk3, disk4 and disk5. So you have to perform jar operation. We can, if you perform jar operation 0 1 0 0 with the help of, we have seen, we'll get this. Is suppose present, this is the data, right? So in red in week 11 open session, we have discussed in detail red 5, right? So you can also watch red, what is it, how to recover this. So Apple, you got it?
So when XOR operation between 0100 and 0100.
Yeah. So you have to remember
disk 1 and disk 3 is what we will do
no.
XOR operation.
Yeah, we have to jar operation all the, if you recover this, you have to perform jar operation all the data item, right? So 0 1 0 1, then you have to first 0 1 0 0 0 1 0, then you have to perform jar operation 0 1 0 1. So if you jar operation 0 0 0 0, then you have to perform the jar with the help of this result. You have to jar operation with this, right? You have to this jar operation, you will get 0 0 1. Then this result you have to jar operation with this, right? So you can, it will 0 1 0 0. Okay. And now so this is the 0 1 0 0. Now we have to, for recover this data, you have to perform jar operation this and this. So let's perform the operation 0 1 0 1 0 1 0 0. So what we'll get? 1 1 0 1. This is the odd number of 1, right? 0 0 0.
You can perform the XOR operation in one go, right? For
Yeah, yeah.
all four. You do the same also.
Anyone? Hello.
Can you hear me?
Yeah, yeah. Please tell me.
I'm saying if you perform the XOR operation on all four, it will still give the same answer.
Uh, from which?
This 1, 3, 4, 5. When you perform the XOR operation one by one, 1, 3 you do now. Then you do for 4.
Oh yeah. For 2, okay. Let's perform the operation. Then we'll get the result, right? Okay. So 0 1 0 0. Right. So we already performed. Right. Then you have to perform with the help of this, right? 0 1 0 0. Then 1 0 1 0, right? Okay, you will get the same result. It may be same result or may not be same result. So this option will be correct.
So what he was saying is instead of doing 1 with 3, then answer with 4, then answer with 5.
It will be give the same result.
So we can do these OR operations together. One.
Yeah. See, if you do the XOR operation together, so I'll tell that trick, right? So let's
Yes.
No matter in which order you do, and it will always yield the same answer. You don't even have to write it down. You can just calculate it right from the disk itself.
Okay.
Yeah, it's just the odd number of ones.
You take the first element of all the disk and write down the answer. That's how it works.
Okay, you can see that this is the how many numbers of 1. This is the even numbers of 1, right? Hello.
Yes.
Hello. So this will be the 0.
0.
0. You can see that there are 3 numbers of 1. So 1 and 0. So you can for the help of understanding, I have XOR operation between 2, but you can do in the 1 also. Okay. Okay. Now next question. Assume the binary value represent 8-bit ASCII code. What is the data what present inside the RAID 5 storage system? So that's it is. So we have to tell the data, what are the data present in this. So in RAID 5 priority bits, this is the priority bits and this is the priority bits. While in RAID 4, please remember, in RAID 4, suppose this is the disk 1, disk 2, disk 4. In only one disk will be the priority disk, right? But in the RAID 5, priority disk is distributed. So this is the priority disk and this is the priority disk. So data is not present in priority disk. We have that for priority disk, for recover priority disk is used, right? So this data is not present in these 2 bits, right? So what are the data is present in this, right? So we have used 8-bit ASCII code, right? So we have used 8-bit ASCII code. So 0 1 0 0 1 0 1 0 0. For 8-bit, you have to take this also, right? 0 1 0 0. So if you convert this binary to in decimal, right? So this will be the 68, right? Hello.
Sir, I don't understand one thing. How did you find out which one is parity?
In disk 5, this is the parity disk and this is the parity disk is distributed, right? Suppose disk. Okay, let's take disk 1, disk 2, and disk 3. Suppose So this will be the parity disk, this will be the parity disk, and this will be the parity in red 5.
Okay,
While
okay,
in
okay, okay.
while in red 4, I'm again. Please remember also in red 4. Parity disk will be only one disk, right? So this will be the in red 4 parity. This will be the parity, and this will be the. But in red 5, parity disk is distributed, right? So this is the red 5 question. Hello.
Understood, sir. Yes, understood.
Yeah. So this is the red 5 question. So we'll see that with the help of. So we have used 8 bits, right? We have used 8-bit ASCII code. So 01001 and 0100. If you convert into this in decimal, it will get 68, right? So this is the value of, if you ASCII, this is the capital D. Hello.
Yes, but how do we know this? I mean,
okay, so it will given in the it will given in the question.
Okay,
65
okay.
equal to A. I think 65 equal to A, 66 equal to B. If it is the given 65 equal to A, right? 67 equal to C, 68 equal to D, right? So this is the value of 60D. This will be the. Then we have to see that this and this 0 1 0 0 and the 0001, and this is the value of 65, right? So 65 is capital A. Then this is the parity, right? So it will not store data. Then 0101 and 0100. So this is the right 84. So this will be the capital T. And 0101 0100, and this is the parity bits. So this will be the use 0001. So this will be the 68. So this is the right. So data is present in the bits. Everyone got it? How to solve? If it is the red 5, again I'm repeating. If it is the red 4, if it is the red 4, then this will be the parity disk, and this will be the parity disk. Data is present. This, not this. So other than the parity disk, in red 4, data will be stored.
Okay,
everyone got it?
So you just leave the parity disk and then write down everything else. Right?
Yeah. So you have to write down the if it is 8-bit, then you have to write both together 0101 then 010 8-bit. If it is even 8-bit, right? So you have to the two bits combine 0101 then 0100. Right? So if you have to find the binary to decimal numbers, you can the 68, then will be the D. Then again, then the next 8-bit, you can say that this will be the, we have written this. The next 8-bit, this, then we have written this. Then next 8-bit. So this and this is the parity disk, right? This.
So the first one would be 2 raised to power 7, right? And then 2 raised to power 3.
Okay.
2 raised to power 6. Huh?
Okay. This is the 2 to the power 0, 2 to the power 1, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, 2 to the power 7. Right. Okay.
128.
So it should be 2 to the power 6.
The third one is 2 to the power 2.
Okay. Oh, yeah. Sorry. There's a mistake, sir. This is the 2 to the power 0. With the 1, 2, 3, 4, 5, 6. 2 to the power 6.
Okay. Raised to power 6.
Yeah.
Okay.
So sorry, small mistake.
64 plus 4. That's 68. Yeah.
Yeah. So and in red 4, I'm explaining this will be the parity disk. In red 5, parity is distributed, so this will be, so the red for only one disk is parity disk. Okay, so we'll move to the next question. So this is from week 12 question. Okay, consider the information given on relation job and relation assignment, relation job and relation assignment given, and answer the question 5. Right. Consider worst case memory availability, assuming assignment as outer relation. Identify the correct cost estimate for nested loop join assignment and job. This is the A, B, C, and D. So this is a nested loop join. We have to find the numbers of block transfer and numbers of seek required. In nested loop join, numbers of block transfer equal to NR into BS plus BR. NR is the numbers of record in outer relation. Numbers of record in outer relation. And numbers of block in inner relation. Inner relation, right? And BR is the numbers of block in outer relation. In outer relation, right? So you can see that NRs. So you are assuming assignment as outer relation. So numbers of block, numbers of record in assignment is 5,000, right? In then numbers of block in inner relation. Numbers of block job is the inner relation. So numbers of block in inner relation is 100. Then numbers of block in outer relation. Numbers of block in outer relation is 300, right? So there will be 500 300 block transfer. Everyone got it? If you have any problem in this question, you can ask. And how this formula come? We have derived how formula this come in week 12 activity session. You can, if you have doubt how this formula came, you can watch week 12 activity session.
So we are not doing the block transfers for BR, right? No, all the
No,
rows.
yeah, you have to find the total numbers of block transfer. We have used nested loop join and assignment as outer relation. You have to find the total numbers of block transfer. So in the nested loop join, block transfer formula is NR, where NR is the numbers of record present in outer relation. So you can see that 5,000 numbers of assignment is outer relation. Total numbers of record present in outer relation is 5,000. Then BS, total numbers of block in inner relation. So total numbers of block job is the inner relation, right? So total numbers of block in inner relation is 100. Then total number plus total numbers of block in outer relation. Total numbers of block in outer relation is 300. So it's 300. Right. So you got it, or you have any doubt?
Can you explain it again, please?
Okay. Consider worst case memory availability, assuming assignment as outer relation. Identify the correct cost estimate for nested loop join. So in nested loop join, total numbers of block transfer formula is NR. NR means total numbers of block in outer relation, plus into VS, total numbers of this. So NR means total numbers of record in outer relation, and BS means total numbers of blocks in inner relation, plus BR. BR means total numbers of blocks in outer relation. So total numbers of record in outer relation is 5000. You can see that total numbers of record 5000 into 100. Total numbers of block in inner relation plus 300 total numbers of blocks in outer relation. So this is the total. If you want to how this formula come, we have derived how this formula come in week 12 activity session. We can watch also this.
Okay.
Okay, now we have to find the total numbers of seek required, right? Seek equal to NR plus BR, right? Where NR is total numbers of record in outer relation and total numbers of block in outer relation. So you can see that NR plus BR, total numbers of record in outer relation is 5000, right? 5000 plus total numbers of block in outer relation is 300. So total numbers of seek required is 5006. Everyone got this question? Okay, we'll move to the next question. So in previous case we have used nested loop join. In this case we'll use block nested loop join, right? So we have to find the total numbers of block transfer and total numbers of seek required, right? So total numbers of block required in block nested loop join. BR into BS plus BR, right? So what is BR? Total numbers of block in outer relation. And this total numbers of block in inner relation, and BR is total numbers of block in outer relation. So we can see that total numbers of block in outer relation is 300, right? 300 into total numbers of block in inner relation is, you can see that assignment is the outer relation. So this is the outer and this is the inner, right? Total numbers of block in inner relation is 100 plus total numbers of block in outer relation, right? So it will be 300. So you can say that 30300 block transfer required. Sorry. And the total numbers of seek required is 2 into BR. BR is total numbers of block in outer relation, right? So total numbers of block in outer relation is 300. So 2 into 300 equal to 600 seek required. So everyone got this question? If you have any doubt, you can ask.
Got it. Is there any tip, memory tip for remembering this formula?
See, if you understand how this,
some kind of phrase or anything out of experience that you know.
Okay, okay. Let me explain how nested loop join work and how block nested loop join work. You got it.
No, I mean, I understood. Just to memorize the formula quickly, I was asking, is there some tip? For example, the trigonometric functions, we know a very common phrase, right? So similarly for this, is there something? If not, then we can move to next topic. Otherwise, I don't want to take too much of your time.
Yeah, see,
Yeah, so if you understand that derivation of this, so you can simply derive this formula, or otherwise only just two formulas are there for block nested loop join. So you can simply remember this, right? But you have to see which is the outer relation. Okay, so based on you can apply this formula, right?
Yeah. Okay.
Yeah.
Okay, we'll move to the next question. So consider the following relation: employee, EID, ename, contact, salary, then project, PID. This is also from practice assignment question. PNAME, location, and duration. And the allotment EID, PID is the primary key, EID and PID, that and that of allotment. Then you have to identify the most optimized expression tree from the given option. That's find out the name of all the project allotted to ename Raj, and the project location is Chennai. We assume employee allotment is much larger than allotment project, right? So you have to tell the most optimized query. So you can see that option 2, in option 2, selection is operation, selection operation, Pinam equal to project, and location sigma location equal to Chennai is before then option 1. As early as possible, option 2 is perform selection operation in before, means you can, if you compare option 1 and option 2, selection is operation is performed in this part. In option 2, selection is performed in this. If selection operation is performed, you can, if you the size of join, means numbers of tuple returns, you can see that numbers of tuple, it will reduce the number numbers of tuple returns the following query, and the join will be the more efficiently, right? You can see the allotment, it directly return on the natural join, right? It will join after the join operation, selection operation is performed. But in option 2, selection of before join operation, selection operation is performed. So you can say that option 2 is option 2 is more efficient, right? Efficient than option 1. And compare option 2 and option 3. You can see that we have taken only the projection operation of EID and the PID and PNAME, right? So we can see that option 3 is more efficient than option 2. And if you compare option 3 and option 4, you can see that selection operation performed here and here, and we have taken natural join. So option 4 is more efficient than option 3, right? So we can say that option 4 is more efficient. So everyone got this question?
Sir, it says that the employee natural join allotment is much larger than allotment natural join project.
Yeah.
So you would prefer to You won't prefer option 3 or option 4.
Why allotment and project?
Because that's the bigger relation. So you take the natural join there first and then.
Yeah. View. Yeah. You can also means select by this allotment, and this is the smaller operation, right? So you can see that allotment and project is smaller operation. So you can we assume employee and allotment. So you can see that it is perform employee and allotment operation, right? So we can select by any way, right? So we have to see the which performing selection operation is as early as possible, right? So that will be the most efficient part.
Between option 3 and option 4 will be the choice.
Yeah, option 4 will be the choice.
Yeah, because in the question we have mentioned that employee natural allotment is much larger than allotment natural project, right?
Yeah.
So the number of tuples for the allotment project will be less.
Less.
Right.
Yeah.
So the cost
Yeah.
for fixing the record will be less. Yeah. So that's why option 4 is more efficient.
Got it.
Yeah. Okay, so if you have any doubt in week 10 to 12, you can ask.
Okay. Any doubt in any week, like week 1 to 12, anything? So this is the last session.
Week 12 practice assignment question 2 and 5.
இன்னும் தீப்பெட்டியோட தான் சுத்திட்டு இருக்க இன்னும் தீப்பெட்டியோட தான் சுத்திட்டு.
Hello, Steve. Okay. Yes, Apul. Which question?
Week 12 practice assignment question 2 and 5. So this is basically on cost. 5 is okay. If you can just explain question number 2 from practice assignment week 12.
Okay. Question number 2.
Which question? Week 12. Which question? Practice assignment.
Practice assignment question number 2.
Okay.
So that is directly from the slide, I guess, right? Very process just told that. So that question is directly from the slide. You can refer to the slides.
Apul.
Yes. Okay.
Apul, you can see the second statement. Cost to write to a block is less than the cost to a read block. So you can means everyone know that cost to write a block is greater than the cost to read a block, right? Hello.
Yeah. Okay.
So option 2 is false. Hello.
Yeah. Okay.
And query cost is generally measured total elapsed time for answering queries. So you can see that directly from slide also. This how query cost is generally measured. So this is the total elapsed time for answering that.
Okay.
And anything?
So last question. Fine. And graded assignment 12.
Yeah, graded assignment 12.
Question number 3.
Question number 3.
Over here, if you can just help me to not the answer, but quickly, if you can just help me to interpret it, that would be helpful.
Okay. Okay. So I think this question Is I think week 12 practice open session. Pradeep is explained in very detail way how to interpret this. So you can watch also this session.
Live session?
Yeah, live session week 12.
Yeah,
Practice
in
session.
live session, in the live session I explained everything.
Okay, we'll take it up. Thank you. Thank you very much.
Hello, sir.
Yes, Richie. Yeah.
Hello.
Can you tell me the name of that PDF?
Yeah, I have just shared a PDF. Like I have a problem in the like the week 7 problem where cursor.fetchMany2 is given and the result is showing as 4. I have a doubt. Like, why is it 4?
Can you be little louder? Like,
am I audible?
Yes.
Yeah, the thing is like in the same PDF file which I shared, the page number 152, I have a doubt. In that Python database connectivity problem, there is like cursor.fetchMany is given over there and the parameter is fed inside that 2. So the result is showing as 4. So like I just have a doubt. Why is it 4?
There are 4 PDF. Can you explain in which PDF? Hello.
Okay. Is it 4? Like, just a minute.
Hello. Yes, Richie. Yeah.
Yeah,
If you see the code here, you can see result equals to cursor.fetchMany2, right?
Yes.
But what we have printed, print cursor.row count. We have not printed the result. We have printed the cursor.row count. It is simply counting the number of rows.
Okay, the total number of rows available.
Yeah. So result equals to cursor.fetchMany2, but we have not printed a result, right?
Okay. So cursor. Okay, I got it. Thank you, sir.
Okay. Is there any other doubt? Okay. Thank you then. This is the last session for DBMS and all the best for your interim exam. Okay.
Piyush, Subendu, Pradeep, thank you very much.
Yeah, thank you. All the best
And
for
all
your
the best,
interim exam.
everyone.
Thank you, sir.
Yeah.
Thank you. Bye-bye.
Thank you, sir.
Thanks a lot, sir.
Yeah, thank you.